So today, guys, we're going to be talking about the quadratic formula, which is going to be used to solve for the x value for any quadratic function. All right, and the formula says that x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. In this top box, I put everything in parentheses because sometimes that helps us out when like a, b, or c are negative numbers. In the bottom, I just put the more general formula that you should normally see for the quadratic formula. And this looks like a whole complicated piece of information, but really this is going to come down to working out about 2 or 3 steps, maybe 4 in some cases. And this will always work whenever you can't factor something or whenever you don't feel like completing the square. The quadratic formula is just another method to give you some of these solutions. So what I've done is I've put together a list of how we can get our solutions. And remember, these solutions are just these values. So where the graph crosses the x-axis. All right, and what we're going to look at is something called a value of the discriminant. All right, and the discriminant is the part that is under the square root in the formula. So you can see b squared minus 4ac, all right, right here. Okay, this part under the square root is going to tell us how many zeros, all right, or how many solutions that this has. Okay, so if b squared minus 4ac is greater than 0, all right, if it's positive, then we're going to have 2 real solutions. So we're going to have 2 solutions, all right. One's going to be, maybe x, maybe here x is 3, maybe here x is negative 2, okay. Again, if it's greater than 0, we still have 2 real solutions. There's 2 cases. Either the discriminant is a perfect square, like for example, it could be the square root of 16, and in that case, my answer would be positive 4 and negative 4. Okay, or we could have that it's not a perfect square, and that could be like the square root of, say, 18 or the square root of 17. All right, and we know that that's going to be just a long decimal when you type that in your calculator. It's going to be still on the graph, but it's not going to be a nice whole number integer that we want. Okay. Then we have if b squared minus 4ac is equal to 0. That means that we have 1 real root. All right, that means that right here, 1 root, all right, 1 place that the graph touches our x-axis. And then the last case, if the discriminant is less than 0, if it's a negative number under there, then we know that we're going to have 2 complex roots, some complex numbers. We know that somehow there's going to be an I in there, a positive and a negative, something I. And this is what our graph looks like. The reason why it doesn't have a real root is this graph never crosses the x-axis. Okay, so let's see how the quadratic formula is used in action right here. All right, so our first example is we're going to have 2 rational roots, all right, or 2 real number roots. And so the first thing that I like to do is I like to think about this as a squared minus bx plus c, and I've got to get my a, b, and c labeled first. That always just helps me set the problem up, and we can go from there. Then I'm going to write down what the quadratic formula is. Negative b plus or minus square root of b squared minus 4ac all over 2 times a. Okay, and then the next step, I'm just going to plug everything in. All right, so x equals negative b, b is negative 12, plus or minus the square root of negative 12 squared, minus 4 times a, which is 1, times c, which is negative 28. And we know that all of that is over 2 times a, which is 2 times 1. Okay, and so now this just turns into a simplification process. All right, if I look at under the square root part, I get that x is equal to Negative negative turns into a positive 12, all right, plus or minus. We have the square root of negative 12 squared is 144. Negative 4 times negative 28 is going to give me positive 112. All right, and all of this is over 2 because 2 times 1 is just 2. And so what does that give me here? That gives me 12 plus or minus the square root of 256 all over 2. All right, and then we're going to put 256 in our calculator. And luckily enough, 256 is a perfect square. So we get 12 plus or minus square root of 256 is 16 all over 2. All right, and this gives us, what is that, positive 2 cases here. So we have 12 plus 16 divided by 2, which is 28 over 2, which is 14 for one of our x's. And we have the other case, which is 12 minus 16 over 2, and that's negative 4 over 2, which is going to give me a negative 2. And so we know that our graph, all right, is facing up because A is positive. And you know that one of your x's here is at negative 2 and one is at 14. All right, and we know that those are the zeros, and our graph has some kind of look like that. Okay? Let's look at another example. Okay, so in this example, we have x squared plus 22x plus 121 is equal to 0. So A is equal to 1, B is positive 22, C is positive 121. So here we have x equals, all right, we have negative 22 plus or minus, we have the square root of 22 squared minus 4 times A is 1 times C is 121. All right, and all that is over 2 times A, which is 2 times 1. All right, and so we're going to go simplify. So x equals negative 22 plus or minus the square root of 22 squared is 484. Negative 4 times 1 times 121 is a negative 484. All right, and all that is over 2. Okay, so this gives us x equals negative 22 plus or minus the square root of 0 all over 2. Well, the square root of 0 is just 0, so this is negative 22 plus or minus 0. So really this is just negative 22 over 2, which is negative 11. And so our one rational root here is negative 11. And like our chart told us, this is going to tell us that negative 11 is my one spot that it crosses the x-axis. And since A is positive, it's telling us that our graph is going up right here. Okay, let's look at a third example. So in this example, we're going to look at something that has irrational roots. Okay, so in example 3, we have 2x squared plus 4x minus 5 is equal to 0. And so A is equal to 2, all right, B is equal to 4, and C is equal to negative 5. All right, so we're just going to plug all this into the quadratic formula. So we have negative 4 plus or minus the square root of 4 squared minus 4 times A, which is 2, times C, which is negative 5. All this is divided by 2 times A, which is 2 times 2. Okay, so simplifying everything under the radical, all right, we get negative 4 plus or minus under the radical or under the square root. 4 squared is 16. Negative 4 times 2 times negative 5 is going to be positive 40. All right, and all that is over 2 times 2 is 4. So what does that give us? That gives us x equals negative 4 plus or minus the square root of 56 all over 4. And we could kind of simplify some things here. For right now, I'm going to let us leave it like this. We're going to talk about simplifying some square roots, kind of what we could do in order to help us out in that. But for right now, let's just leave it -4 plus or minus square root of 56, all divided by 4. So that's going to be our solution. So these are going to be long decimals, all right? Kind of nasty numbers for us to deal with, not nice and pretty whole numbers, whole integers. Okay, let's look at our fourth example. Okay, so in our example 4, we have that x squared minus 4x is equal to 13. And something that's kind of tricky on this one is we need to get it in the normal form. So we're going to just rewrite this as x squared minus 4x plus 13 equals 0. Now that's going to let us get what our a, our b, and our c is correctly. All right, b is -4, c is 13. So if we're going to go plug this in to our quadratic formula, we've got -b, which is -4, all right, plus or minus the square root of b squared, so -4 squared, minus 4 times a, 4 times 1, times c, which is 13, all over 2 times a, which is 2 times 1. So here we have, just simplifying, +4 plus or minus the square root of 16 minus 52 all over 2. And so what does that give us? That gives us x equals 4 plus or minus the square root of -36 all over 2. We know that you can't have the square root of a negative number. We know from our previous learning that this gives us 4 plus or minus 6i all divided by 2. The cool thing about this is this can be simplified. So 4 can be divided by 2 to give you 2, and 6i can be divided by 2 to give you 3i. And so this answer, you have x equals 2 plus or minus 3i. And that's the answer to your problem. This one's going to have complex roots. So this one is going to have something where it does not cross the x-axis down here. All right, so that's how you use the quadratic formula, and using the discriminant, which is the numbers under the square root, to solve problems for quadratic functions.